Okay, this is a question about the stoichiometry, and which is related to more quantitative analysis, analytical chemistry types of question. And let's try to see what information they are asking. How many moles of oxygen are required to produce 2.33 moles of water? And the equation shown in the bottom is was given, and then we are trying to figure out and this what this means. So this compound called, this is actually called a thiol, and then this thiol SH compound, carbon with a SH compound and oxygen, they all react with a ratio of let me put it this way, right? This is a 1, if you don't write it, and there's a 6, right? And the question of the concern is the what we call the water versus an oxygen. And let's look for this. Okay, there is an oxygen here, and there is the water. So what that means is 6, just focusing on this, 6 moles of O2 will produce 4 moles of H2O. 6 molecules of O2 will react with the other compound to produce 4 molecules of H2O. So we can also multiply by Avogadro's number. So it says 6 moles of H2O will react to produce the 4 moles of H2O. And now what that means is now, okay, so O2 moles consumed over H2O mole being produced essentially is a ratio. They will use 6, they will produce 4. So that's how they corresponding to each other. In the problem, what we're saying is I want to know how many moles of oxygen. So that's my x. And then the 2.33 moles of waters are being formed, right? So therefore, x mole of O2 is 6 over 4 times 2.33. That will lead to me 3.50. So the answer is C. This number problem 24 asking is what is theoretical yield of H2S? So H2S is shown up here, and so they are being produced by reacting with aluminum sulfide and the water shown up there. So let me rewrite it. Aluminum sulfide, water, it will react. It will produce 2 moles of aluminum hydroxide plus 3 moles of H2S. And then in the beginning, in the initial, and what was happening is they give 4 moles of Al2S3 and 4 moles of water is being present, and then nothing was given on the other side. And then this will gonna react to consume both sides. And because it was not giving a stoichiometric ratio, 1 will run out first. If you look at that, it is being used 1 to 6 ratio, right? So which one will be completely used? That's 4.0 will be completely used, while the Al2O3 will be 4.0, and they only use 1 over 6, right? 1/6 of the amount it will be used. So minus means they're being consumed, and this is essentially unit of Al2O3 being used, whereas this one is essentially completely used. In other words, I find out the water is limiting agent. Okay, so this is actually, this is a key point, is figuring out which one is the limiting agent. So this is a change, and the equilibrium, right? Under the equilibrium E, I will have nothing, and that's what make this one the limiting agent. And then this one you will have 4 minus 6 over 4. We'll go figure that whatever the moles of this Al2S3 were remaining. And now what's going to happen for the other side is by consuming this much, we are going to produce. So this amount of 6 over 4 with the building ratio, I'll use 1, they'll produce 2. So you are generating 2 times of 4 over 6 Al2O3 moles that has been used, and this one is being generated, and this one is being generated 3 times 6 over 4. So the answer for this one is, I guess, is 6 over 8, which is 3 over 4, and this one is 6 over 12, which is 2. So that is what's remaining at the end as a product. And the question is, how much S2H2S do you have left? And that's 2 moles. So answer for this one is A, which is 2.0 moles. Okay, so this is the last question of the exam 2. And this is what we call the concentration dilution. Let's say you have a beaker or volumetric flask with their concentration is M1 and their volume is V1. And now you add water to make it even a bigger container. I guess that's a volume 2. And their concentration is M2. So the relationship is molar concentration of case state 1, concentration 1, molar concentration of state 2, and their volume 2 remains the same. This is concentration times volume is number of solute in the solution. It doesn't matter though. You essentially only add solvents. So number of moles of solute conserve, and this is an equation that probably you have seen it before. And so now we just have to plug it in the right number. So concentration 0.0887 mole times, they want to know what is the volume of this solution. So I would just say volume 1. And what about the volume and the concentration over here? 0.0224. Volume is 275.0 milliliter. So therefore, volume 1 is 0.0224, 0.0887 times 275. That lead me to 69.4 milliliter. Okay, so 69.4 milliliter. Okay, so now this is the end of second exam. Okay, thank you very much.